So this is part 2 of the power rule. We're going to start some application questions now. The first one, number 8, says to find the equation of the tangent line. So equation of the tangent line to the curve y equals negative 2x plus 4 at the point where x is 3. So if we look even on the graph where x is 3, we would be expecting our tangent line to have a fairly steep negative slope. But we want the whole equation of it. So let's go through how to do it. So the first thing I would want to do is find the derivative, which is the slope of the tangent anywhere. So since that's our equation, to find the derivative it would be negative 4x plus 0. Then we want the derivative at 3, so we can actually write y prime at 3, which is going to give us the slope of the tangent at 3. And y prime at 3 is negative 12. We also want the equation of the tangent line. So again, this is the slope of the tangent. And we can do it either using our y equals mx plus b or our vector method. Okay, I will show both. So using y equals mx plus b, we just found out that m was negative 12. And to get the point, we would sub 3 into our original. So y equals negative 2 times 3 squared plus 4. So that's negative 18 plus 4, negative 14. So does that look right? 1, 2, 3, negative 14. Yep, not even on the graph, so we're good. And then we use y equals mx plus b. So this is our x and our y. So then we want to add 36 to both sides and get that b was 22. All right, so that means therefore the equation of the tangent line would be y equals negative 12x plus 22. Now let's see if we can get that using the vector method here. So that would be our direction vector gotten from the slope, so change in y over change in x. So our direction vector would be 1, negative 12, which means our normal would be 12, 1. And our point, we already figured out q is 3, negative 14, and then p is xy. And then we use QP dotted with the normal equals 0. So QP is going to be x minus 3, y plus 14 dotted with 12, 1 equals 0. 12x minus 36 plus y plus 14 equals 0 gives us 12x plus y minus 22 equals 0. But if we rearranged it into the form y equals mx plus b, we would definitely get y equals negative 12x plus 22. So this is standard form or scalar form. And this one is y equals mx plus b or slope-intercept form. Doesn't matter to me which way you put it in, unless they specify in the question from the textbook, which sometimes they do. But on a test, it wouldn't matter to me which form you answered it in. Okay, so next one. Next application, find the points or points, so there could be more than one on the curve, y equals x cubed minus 3x squared, where the tangent is horizontal. So if I was just teaching this lesson right in front of you, I would say, what does it mean for the tangent to be horizontal? And hopefully someone would say that the slope of the tangent would be 0. Okay, so tangent is horizontal means its slope is 0. So the first thing I do after knowing y would be to find the derivative, y prime. So that's going to give me 3x squared minus 6x using the power rule. But I just said that y prime, or they want me to find where the tangent is horizontal. So y prime means slope of the tangent anywhere, but specifically I want to know where it's equal to 0. So I can replace y prime with 0. and then I want to find the value or values of x where the slope of the tangent is 0. So what I would try to do on this side is factor if I could, and I can factor out 3x. And then I've got three things multiplying together. I've got this 3 out front, which is no big deal. I've got x, and I've got x minus 2, all multiplying together to give me 0. So there's no way that the 3 can change because it's a constant. But if I multiply by x, and x happens to be 0, then this whole side would equal 0. So x equals 0 is one of the places where the tangent is horizontal. And for x minus 2 to be 0, x would have to equal 2. So those are the two values of x where the tangent is horizontal. But they want full points, so I need to get the y values that go with x being 0 first of all. So that's going to be 0 cubed minus 3 times 0 squared, so y equals 0 as well. And here it's going to be y equals 2 cubed minus 3 times 2 squared, which is going to give you 8 minus 12, which is negative 4. So therefore the tangent is horizontal at the points 0, 0, and 2, negative 4. Okay? All right, so that's our second application question, number 9. Moving back on, number 10. Find the slope of the tangent, so just the slope, that's nice, of the tangent to that curve at this point. So again, this time though, I would actually change how y is written before I find the derivative. So I would write it as y equals 3x to the negative 2 minus 4x to the negative 3. And now I can find y prime. So again, when you write y and when you write y prime, very important, you're showing me that you know when we're just talking about the function versus when we're talking about the derivative, which is a formula for the slope of the tangent. So we've got negative 6x to the negative 3 plus 12x to the negative 4, which we could write as negative 6 over x cubed plus 12 over x to the 4th. But we want the slope of the tangent at that specific point, so we actually want y prime at 1, or negative 1, sorry. That's our x value, negative 1. So we could sub in negative 1 in for x into this formula we made for the slope of the tangent. And y prime at negative 1 turns out to be, so it's going to be positive 6 plus 12 or 18. So therefore m tangent equals 18. We did what they asked us to do, figured it out, we've got it. All right, so the next question, we want to find the equation of the tangent line to the curve f at x equals x to the 4th minus 3 root x at the point where x equals 1. So we're back to equation, which is a little bit more involved, but in order to find the equation, you still need the slope of the tangent. So first of all, we're going to rewrite f at x so that it's in a friendlier form to find the derivative. So I'd write it as minus 3x to the half. Then find f prime at x. So 4x cubed minus 3 halves x to the negative 1 half. F prime at x, just write it nicer. So that's going to be minus 3 over 2 root x. Okay, so now we want f prime at 1. So f prime at 1 is going to be 4 minus 3 over 2. F prime at 1 is going to be 8 over 2 minus 3 over 2, or 5 over 2. So I think I'm going to do this from a vector perspective, although you're welcome to do y equals mx plus b. So my direction vector is 2, 5, which means my normal is going to be 5, negative 2. My point Q is 1, and then if I sub 1 in up here, I get 1 minus 3 root 1, which is negative 2. And my P is XY, and then QP dotted with N equals 0. So I've got X minus 1, Y plus 2, dotted with 5, negative 2 equals 0, 5x minus 5 minus 2y minus 4 equals 0. So we end up getting 5x minus 2y minus 9 equals 0. Okay? And that's the equation in standard form. So just add a little therefore, and we've got our equation of tangent line is equation of tangent line. Okay, our next question. Find the pointer points on the curve f at x equals, so we have this big polynomial function here, where the slope of the tangent is 15. Okay, so first we would want to find f prime at x. In general, so it would be 3x squared plus 4x minus 5. And we want to know when is that slope of the tangent equal to 15. So that's a quadratic equation we formed, so we would want to set it equal to 0 by subtracting 15 on both sides. And then we want to solve that quadratic equation for x. So we could either use the quadratic formula, if you're a quadratic formula person and you like to solve everything using the quadratic formula, or we would hope that this could be factored, but it would be able to factor by decomposition because the coefficient in front of the x squared is a 3. So we'd need terms that multiplied to negative 60x squared and added to 4. So we could think about 60 and 1, no way, 20 and 3, we're going to end up with 4, 6 and 10. Okay, so 6 and 10 are going to work with a negative 6x and a positive 10x. So what has more in common with 3x squared? It would be the minus 6x plus 10x minus 20. Common factor just the first two terms. 3x is in common. Sign that comes next has to go next. 10 is in common with the last two terms. Then you end up with a binomial common factor of x minus 2, and then 3x plus 10 form the other binomial. So now you want to know, if you multiply these two numbers together, it's like a times b, and you have to end up getting 0. So either this one's going to have to be 0, which means x would have to be 2, or this one's going to have to be 0. So x would have to be negative 10 over 3. So those are our two x values that make the tangent 15. Corresponding y values, the 2 is easy. We can sub 2 in fairly easily. And that's going to give us 8 plus 8 minus 10 plus 2, which is 8. 16 minus 10 is 6 plus 2 is 8. So that means one point is going to be 2, 8. The other point is going to be harder because we're dealing with a fraction. So we have negative 10 thirds cubed plus 2 times negative 10 thirds squared minus 5 times negative 10 thirds plus 2. So that's going to be 1,000 negative over 27. And then we've got 100, so plus 200 over 9, plus 50 over 3 plus 2, so 27 is going to be our common denominator. So this one already had 27 times 3, so it's going to be 600 here, times 9, 450, and then times 27, 54. So it's going to end up being negative 1,000 plus 600 plus 450 plus 54. So that gives me 104 over 27. I don't think that reduces. Nope. So that's going to mean therefore M tangent equals 15 at 2, 8, and also at negative 10/3, 104 over 27. Those 2 points. Okay, so that one was trickier. But the fraction part was probably the trickiest part, and then remembering to factor by decomposition, but you could have used the quadratic formula and also got 2 and negative 10/3 as your solutions. Okay, last question. All right, so first of all, we're talking about the normal to a curve. You should know that from vectors. So the normal to a curve at a point is the line perpendicular to the tangent at that point. So find the equation of the normal to the graph of f at x equals 4x squared minus 3x at the point 1, 1. So the normal is going to be perpendicular to the tangent. So we should be able to do this. F prime at x, they've given us a graph, so we can look at our answer, is 8x minus 3. So f prime at 1, since we're given the x value of 1, is just going to be 8 minus 3, which is 5. So that means M tangent is 5. So we know that M perpendicular, since the normal is perpendicular, is going to be negative 1/5 using the negative reciprocal. So we know our direction vector for the normal is going to be 5, negative 1, which means the normal to the normal is going to be 1, 5. And we have our point. So that's going to be 1, 1. And then our point P, general point XY. So we could do QP dotted with N equals 0. Okay, so now we just have to substitute. So QP is going to be x minus 1, y minus 1, dotted with 1, 5 equals 0. X minus 1 plus 5y minus 5 equals 0. X plus 5y minus 6 equals 0. Okay, so let's look at the point 1, 1 here. Look at our tangent with a slope of 5, so that means we would go up 1, 2, 3, 4, 5 and over 1, and down 1, 2, 3, 4, 5 and over 1. And I don't have a ruler ready, so I will do my best here and sketch the tangent. So the normal is going to be perpendicular. We know its direction is 1, 5, so we're going to go up 1 and over 1, 2, 3, 4, 5, or down 1, 1, 2, 3, 4. Oh, sorry, that was the normal, not the direction vector. The direction vector, sorry, is 5, negative 1, so that means I'm going to go over 5 and down 1. And then over this way 5, so 1, 2, 3, 4, 5 and up 1, and that should be perpendicular, which it looks like it is, to the normal. And we can see that it crosses through just above 1. If we rearrange this, we could see what our y-intercept was. And it is just above 1, 6/5. Okay, and we are done, and I have to go get Abby.